Hello everyone, my name is Tianyi. I'm here on behalf of my co-authors to present a paper titled Sketch2Terrain, AI-driven real-time terrain sketch mapping in augmented reality. Sketch mapping is an intuitive way to externalize spatial memory. It is a subcategory of sketching. It focuses on perception and memory of a space. Sketch mapping is widely used by non-expert mappers, including children, the elderly, and the general public to transfer spatial information. Researchers use it as an instrument to investigate human spatial cognition, decision-making, and information processing. While space is inherently three-dimensional, contemporary sketch mapping methods are limited to two-dimensional representations, such as paper drawing. While this method effectively for planar entities like points, lines, and polygons, this approach challenges non-expert mappers in expressing complex 3D volumetric entities. With the advancement in VR/AR technology, 3D sketch mapping has emerged, but existing tools are very complex for non-expert users. Sketching terrain in both 2D and 3D is extremely difficult. Cartographers have developed techniques such as relief shading and counterlines, but these are labor-intensive or require precise positioning, making them less intuitive for sketch mapping. To address this and use the VR technology advancement, we extend the sketch mapping concept to generative 3D sketch mapping. This is a concept that promotes a new representation paradigm of sketch maps that combine multiple modalities of entities for more intuitive visualization of spatial knowledge communication. Compared to linear and point-based sketch mapping, which is suitable for built environment, adding surfaces as visual feedback can reduce the knowledge barrier to represent complex terrains. This opens new research opportunity and practice applications. Based on this concept, we aim to design a research tool for spatial cognition studies targeting the natural environment, enabling diverse populations to externalize spatial memory accurately and allowing researchers to analyze spatial information of terrains. The design of our prototype follows three main design decisions. First, minimize cognitive load and learning effort. Second, prioritize the user's focus on spatial knowledge, externalization, rather than aesthetics. Third, support whole research workflows across domains and requirements. We developed Sketch2Terrain, a generative AI-driven interface in augmented reality. In a typical sketch mapping task, users first observe a terrain model in a workspace, then sketch it from memory in the same workspace, and iteratively refine it with the AI assistance. Our AI model helps them to convert 3D lines into 3D surfaces in real time. Picture A shows the training data collection mode used to train our AI model. A terrain model is visualized in the workspace, and the researcher can trace it to generate a pair of data. Picture B and C shows the experimentation mode used to conduct user evaluation, including observation and sketching phases. We compared the pix-to-pix model and the diffusion-based model, and we choose the pix-to-pix model for its better inference time and accuracy for real-time interaction. As the number of strokes increases from A to F, the generated surface progressively aligns more closely with the target terrain. We collected 287 sketch maps from mountainous areas all over the world and augment the training data to over 2,000 samples by scaling and rotation. We choose 8 typical terrain types as stimuli in our user evaluation. The main research question related to the accuracy and interpretability of the sketched terrain and landmarks of the new interface, the efficiency, user experience, and task load of the new interface, and does the generated surface match the user's cognitive map and intention. We compared the AI tool to 2D and 3D sketch mapping in AR with 36 participants. After observing a 3D terrain model, participants used one of the interface to sketch the terrain from memory. The video shows the sketching process. This picture shows the example sketches produced by participants for 8 terrains. To answer research question 1, we evaluated terrain elevation accuracy, interpretability, landmark position accuracy, and topology accuracy. To answer research question 2, we evaluated efficiency, user experience, and task load. To answer research question 3, we designed a post-study questionnaire. Our results shows that 2D condition had higher 2D landmark accuracy. 3D condition had higher terrain elevation accuracy, while the AI condition produced more interpretable terrains and more accurate 3D landmarks. Regarding research question 2, 3D condition need more strokes to represent terrains, thus has lower efficiency. The usability of all interfaces is acceptable. Based on the UEQ, AI condition and 3D condition are more reliable than the 2D. Based on the theme TLX, the AI condition reduced stress and perceptual strain. Regarding research question 3, our post-study questionnaire shows that AI-generated surfaces align well with the cognitive model of most participants. Participants generally endorse the fidelity and accuracy of these AI-generated surfaces, believing they reflect their intentions. In summary, AI condition creates more interpretable and accurate landmark and terrain, improve efficiency, and reduce stress and cognitive load. Compared with 3D sketch maps, we find that the 2D sketch map shows interpretability problems due to their abstract nature and the absence of height representation. Compared with the existing method and products, our tools has a streamlined workflow, higher efficiency, and more realistic visualization. Our evaluation suggests that the AI model enhances externalization outcomes. However, user feedback also shows that the AI-generated surfaces could occasionally overwrite their previous memory, especially during the early stage of sketching when the AI-generated surface might differ a lot from the ground truth due to limited input strokes. We also found that sketching strategies differ for different conditions. For 2D condition, users often use the annotation to express spatial relations. For 3D condition, users create the detailed curve network for surface depiction, resulting in the highest stroke count. In the AI condition, with the help of AI, the participant can focus on sketching the mean structure, which increases the efficiency while maintaining the accuracy. Finally, we found that the AI model compensates for variations in individual sketching styles and ability, making it particularly useful for non-experts to sketch an aesthetic result. Potential applications include wilderness search and rescue, accident and crime scene reconstruction, and dream cartography. Thanks for listening.